How are you doing? Okay, I hope you're doing well. So, welcome to my talk. Today I'm going to talk about Ruby. It's a programming language. And this talk is, well, it looks a bit similar to the keynotes, right? And it's not a coincidence because I think this talk is a kind of spin-off to what Matt told about this morning, about upcoming Ruby features and challenges they bring to us. But I'm going to take a look at the different angle from the perspective of the Ruby developers, not from the perspective of language designers or core team members, or whoever making decisions. So I'm going to talk about Ruby next. It's a kind of thing. And as the title of the talk says in the program, that's make old Ruby quack like a new one. So what does it even mean? Let me show you a quick spoiler of what I'm going to talk about today. So assume you have an older version of Ruby, even not the recent one, but the previous. And you want to try this shiny new pattern matching syntax. And it's likely going to fail with something like this, because Ruby 2.5 doesn't know anything about pattern matching, right? What is Ruby next? So in terms of this example, Ruby next is just a simple switch here in the comment, which makes older Ruby understand, recognize, and correctly evaluate the new Ruby. So that's what I'm going to talk about today. Now to the official part. My name is Vladimir. I'm kind of from Russia, but sometimes I live in New York City. I'm working for a company called Evil Martians. We are a distributed consultancy agency with agents and bases all over the world, from San Francisco to Osaka in Japan. And right now I'm here in Nashville, but I'm the only one here, unfortunately. Except from the clients, whoa, it's getting louder. Except from the clients' work, we're doing a lot of open source stuff. You probably heard about some of these projects, and who knows what's going to be next. Maybe it's going to be Ruby next, you know. I'm a Ruby developer, and not only a Ruby developer. You can find me on GitHub. I have some cool projects, probably. And the thing that makes sense in terms of this talk, I'm a gems author. Currently, I maintain dozens of Ruby gems. Not all of them kind of popular, of course, but, well, some of them could be familiar. And that leads us to the kind of first problem, to the situation which brought me here to the stage talking about some kind of new thing. So as a library developer, I have to support all the versions. I can't just use the most recent one because, well, nobody's going to use the library which doesn't support their Ruby version. So I have to stick to at least those Ruby versions which end of life haven't reached yet. And as of now, Ruby 2.3 is officially dead, and Ruby 2.4 is going to be dead pretty soon. So I'm currently migrating all of my libraries to 2.5 at least. But the problem, I want to use 2.7 features. Well, they're really good, and you know, Matt's told about this morning, so we already know about these features. But I can't. So that's the first problem. It's kind of a small problem because it only bothers me as a gems offer. But not every here is a gems offer. Raise your hand if you maintain in a gem. Yeah, so it's about 15%, not so many. Most of you are application developers, right? Who develop applications in Ruby? Yeah, okay, sounds good. We're at RubyConf. But I didn't miss anything. But even if you develop an application, it doesn't mean that you can upgrade your Ruby version right away as it's released. And according to some numbers collected by JetBrains, most of Ruby developers are still using second to last or even third to last Ruby versions, not even 2.6. And which, most important, about a third of all respondents are not going to switch to new Ruby version. Why so? Well, maybe because the cost of upgrade, sometimes it costs something. It's not just changing Ruby version file in your repo. It doesn't worth it because, well, you know, it requires some effort, and not everyone understands what it could bring to me. Performance? Well, yeah, technically every Ruby release brings new performance improvements, But, well, from my experience, that's something that no one cares about when developing applications. Maybe major improvements could force people to upgrade, but not some 2-3% faster hashes or whatever. So this is not usually the case why people upgrade Ruby versions. New features. Well, that should be the case. So we want to use something new. We, as humans, we like trying new things, and new cool features could encourage us to use the latest Ruby version. But until recently, I'd like to say until 2.7, which hasn't been released yet, we haven't had a lot of shiny new stuff with every minor release. But anyway, sometimes there was a reason to upgrade. And I'm going to tell you a short story how I came with the idea so that I want to use modern Ruby features even if I want to support older. It all started about 2 years ago with Ruby 2.5, and one feature caught my attention. Do you know what is it? Any suggestions? What came with 2.5? Yeah, okay. It's a yield self. Well, yeah, it could be, well, why? Why so? I was a bit skeptical at the very beginning because I had no idea why do we need this stupidly named method available for every object. What's the use case for that? But instead of just trying to be against it, I decided, okay, I have to try it to figure out why it's really cool. And going forward, it's cool. And now I'm using it every day. But then I had to, well, I wanted to try to use it, but I was building gems, so I had to backport it somehow. What is a typical way of backporting new features to old versions? Well, this is the way. This is not good way of backporting stuff. And we at Metaprogramming for Good track, and this is not what we're going to talk about. Extending core classes is evil. And even being evil Martian, I'm not so evil to do that in my gems, because that could lead to conflicts and to unexpected behavior. It's probably sometimes okay when you develop an application, okay? But when you develop a library which others are going to use, that's unacceptable. And even with E itself, the chance of collision is pretty low because no one's going to name a method like this. But then another change occurred, and we got a new name, much better name, but this name could be used by other libraries, and actually it's used. So I decided to go another way and started to use another type of monkey patching, which is called refinements. And that's the first thing I'm going to talk about today a little bit. Who knows what the hell refinement is? And who uses refinements? Me. Okay, so a bit of history. Refinements, it's a pretty old Ruby feature. They were introduced in 2.0, but was marked with this very dangerous word, experimental. And even if we remove this label in 2.1, people wasn't going to use it anyway, because they were afraid that, oh, they're still experimental. They're going to be removed in some future versions, maybe, because there were some talks of like this. And there were a lot of, well, real problems and fiction problems with refinements, like inconsistency of functionality. Refinements were getting better with every release, and probably in 2.5 to 6, they finally became 90% consistent. But yeah, they're not going to go away in 3.0, so we're going to live with them for quite a time. So we're going to use them. So refinement is a lexically scoped monkey patch. It means that it somehow takes into account the place from where the method call was made. In other words, it changed the way method lookup work in Ruby. Before refinements, we have a pretty straightforward method lookup algorithm. We go through the ancestor chain for the object class, so it's prepended and included modules, class, singleton class, parent class, and so on and so forth. And we just check every module or class in this chain and whether the method is defined here, and if it is, we use it and apply. Refinements did this small change, which actually turned out to be really big, because now we have to take into account the context of the execution. Hopefully, Ruby already tracked the execution context for every, say, method call to simplify things. And we didn't have to change the way interpreter work, but we changed drastically the way method lookup started to work, which, well, from MRA perspective, that's okay because MRA is the first implementation which added this, but other implementations like JRuby, TruffleRuby, they kind of hate refinements because they're really hard to, well, implement and without losing optimizations they have in JVM, for example. That was another reason why refinements were not so popular, because second most popular Ruby implementation, JRuby, had pretty poor support for refinements until very recently. I can say that the latest version fixed almost all the bugs with refinements. Charles Nutter did a great amount of work, reflected all the way method lookup work in JRuby, and now we can use refinements with JRuby like an MRA, almost. There's still some issues I added recently. So, refinement. Refinement is a two-step operation. First, you define refinement, then you activate it. Defining refinement is almost equal to patching a class. But except reopening the class, you call refine method and pass a block to define the methods inside. So the syntax is pretty similar. And activation is a special method called using, where you tell the current execution context that there is an active refinement in this context. And what does it mean lexical? So let's consider two examples. In one file, we add this using mantra, and another one doesn't have it. We still use them methods. And if we run the first one, it works. And if we run the second one, it doesn't know about the method then because it doesn't define it in this scope. So that's the way refinement works. We can say refinement is a safe monkey patch because it's not leaking anywhere outside of the code you explicitly activate it. That's why I decided to use refinements for backporting new APIs to older Rubies, because it's kind of a safe way of monkey patching. A few notes about what kind of things I wanted to backport to older Rubies. Well, when it was 2.5 era, we had yield self and a couple of useful hash methods, thread fetch, which also make operating with thread local variables a bit more concise. In 2.6, we got then, proc compositions, useless alias array filter, enumerable filter, and a couple of array methods. And finally, in 2.7, again, we already seen this today, enumerable tally, filter map, a couple of time methods, and unbound method, bind call. If you're interested in following Ruby changelog in a good and readable way, I highly recommend to check this website. It's Ruby references GitHub.io Ruby changes. It's maintained by Victor Shepard, who's given a talk on Wednesday. It's a really cool source of truth for Ruby language, for changelogs, for language itself. It's really useful. So Ruby Next as a version 2018, which didn't exist, just was in my mind, was the idea of one refinement which contains all the backported methods for all the modules and classes, and you can just call using Ruby Next, and everything starts working as it is the latest version of Ruby. So for example, in this script, we have filter map, tally, and it just works. So if you come back, it just calculates the number of files with a specific extension in directory. Okay, so this refinement is now operational in those versions in which this method has been implemented, so it's kind of easy to use. Just drop it, use it, and it will make your code compatible from the API perspective with the new, old code will be compatible with new Ruby, vice versa. Okay, so, but then Ruby 2.7 is kind of revolutionary actually release because it brings, for now it's free syntax-related features like pattern matching, number params. Method reference died, canceled, sorry. But I'm still using it, and I'm going to use it in my examples because I like it. And args forwarding. But we cannot refine syntax. So it's kind of impossible. What we can do with syntax instead of refining it and using some Ruby stuff? Well, there is a word called transpiling source code. And eventually, as of now, Ruby Next is a combination of universal refinement for APIs and a transpiler for new syntax features. so transpiling. Transpiling is a compiling source code into source code. So as input, we have Ruby 2.7 source code. As output, we have Ruby 2.5 source code, which does the same. That's not a new idea, of course. If you ever try to build something with JavaScript or CSS, you definitely heard about Babel, which is use next generation JavaScript today, or PostCSS, use tomorrow's CSS today. So that's a very similar idea here. So we want to make it possible to use upcoming features in the current Ruby versions. And the whole process could be described like this. So we get a source code, we parse it with some kind of parser and generate an abstract syntax tree. Then we modify this abstract syntax tree, because working with trees is much easier than working with strings, right? We cannot just rewrite string source code. We need something more object-oriented, probably. And then we generate a new source code with this new abstract syntax tree. Let's take a look at the example. So this is a code, this is pattern matching example for Ruby 2.7. Very stupid, but anyway. Let's talk first about how we can transform source code to abstract syntax tree. There are a number of options in Ruby which we have. The first one is called Reaper. This is a built-in library. And it allows you to generate an abstract syntax tree in the form of array of symbols and other primitives and arrays or whatever. So it's this kind of example. It's been in Ruby for a long time, but the big problem with it, it's version specific. We cannot parse the code written for Ruby 2.7 using Reaper from Ruby 2.5 because it doesn't understand it. It's kind of bundled in the current Ruby version and it cannot be extended. So that's not an option. Anyway, there are some transpilers which use Reaper as its source to AST tool, for example, preval, which do some code optimizations in Ruby code without changing version semantics, but only doing some micro stuff like folding constants, whatever. Another candidate is a RubyVM abstract syntax tree. So it kind of, well, also generates abstract syntax tree in a different form. So this time we get objects with more information than from Reaper, but it's a new thing. It's not so kind of well documented, and I'm not sure anyone except from the authors of this feature use it. And it's MRI specific, so comparing to Reaper, which has been backported to JRuby, for example, RubyVM abstract syntax tree hasn't been yet. And again, the same thing as with Reaper, it's version specific. So we go next, and that's Parser. Parser is a separate gem. Surprisingly, it also allows us to generate abstract syntax tree, but they look pretty readable. The good point of Parser is written pure Ruby. It's version independent, which means you can parse code written for any version of Ruby from any other version. And it's already been used in many tools, actually. One of the most famous examples of Parser usage is the RubyConf gem. So RubyConf used Parser to analyze your code and do transformations. And last but not least, it actually was born into Martians years ago, but that was a lot of time. Another good point about Parser, there is also Unparser gem, which does for us the last step of this operation. So we given an abstract syntax tree, we can generate a source code. And it's not going to be the same source code that you write, because Unparser acts like a very opinionated auto-formatter. So it's don't care about the original source code and how it looked like, but it generates just some stable representation of Ruby source code. So here, for example, we use explicit array instead of this. I forgot how it called. Parser is not ideal. There are some very strange Ruby use cases which it can parse correctly. But, well, I don't know if anyone write code like this. So Parser is good enough, at least for now, to be as a core of this transpiler. So we chose Parser, and the final schema is we parse Ruby code using Edge Parser, which is not an official version. Then we replace AST nodes, and then we generate a new code using Unparser. So this is the same, just written in Ruby code. And this is an example of a rewriter. So for every feature, we have a special class called rewriter, which does this node replacement. So for method reference, which canceled, anyway, it's a good example because it's the simplest transformation we had. We transform this node into this node by replacing methref with send method. That's that simple. Pattern matching is a bit more complicated. Well, actually, it's already, I just added a few dozen lines an hour ago, so it's more than 500 lines of code to just make pattern matching work in Ruby 2.5. And we're going to talk about it a bit more because there's some interesting stuff there. So pattern matching, how to do pattern matching without case in. We can use if-else. Why not? Because, well, if-else can do anything. We also need deconstruct and deconstruct keys for representing non-array or hash classes for pattern matching, and we need to perform some type and structure checks. Well, if any one of you saw the recent talk of pattern matching, you're going to be, so there was something like this explained in terms of Ruby 2.7. But we go to try to rewrite this in Ruby 2.5. So let's try to do this with FizzBuzz program. First, I want to try to rewrite this program as if I wanted to do that knowing which program I want to write, so with some context. How can I write this FizzBuzz from left to right? So we just can compare the array, then we compare elements, and erase non-matching pattern, which is pattern matching specification, if nothing happened. It looks pretty readable and easy to understand, but transpiler should be very, very smart to translate the left side to the right side. What actually is happening in transpiler that we have to call deconstruct even if it's array, because why not? Maybe it has been overridden, I don't know. We should check for the class and raise type error if it's not matching. And we cannot just match the whole array. We have to match elements one by one. And even for this use case, well, even if you can see in the documentation this underscore is a kind of special variable, it's not a special variable. It's a typical local variable. You can even use it in your expression, but it's just kind of not recommended. But from the perspective of transpilers, it's a legal name for local variable, so we have to assign it and pass further. So the code is a little bit more complicated. And if we take a look at the real transpiler code, it's going to be much more complicated for this example. But should we care about it? I don't think so, because this is a version for machines, for robots, for our VM. We shouldn't see this code. This should be somehow auto-generated and hidden, and people should see this, and this is a source of truth. And this is a source of truth for your computer. So comparing these two methods, there might be the question, what about performance? We do a lot of stuff here, really, and this looks pretty simple. I tried to make some benchmarks and was a bit surprised. Well, Matt's already told that pattern matching is slow in 2.7, but it turned out to be twice slower, even more than the transpiled version with ifs and else for this particular example. Well, it highly depends on the code you try to transpile. For example, this code from the documentation, which has really complex pattern matching, is also slower in 2.7 than transpiled version, but not by a factor of 2, but just 15%. But anyway, so I expected pattern matching in 2.7 be much faster than transpiled version, but it turned out that that's not true. Well, okay, we know how to transform source code from one version to another, but in Ruby, unlike JavaScript, for example, we don't have a build phase, right? We do not build our application. We just run Ruby and some file RB, and that should work. How to make it work with RubyNext, how to transpile code in our case. So I'm suggesting two strategies, depending on what you're building. So for applications and scripts or anything else which you want to run on your machine, we can transpile at runtime. And for gems, it's better to transpile at build or release time to package all the transpile files along with the source files. I'm going to talk about it a bit today. Let's start with runtime. So runtime is a big hack. It's a one huge hack around all the ways Ruby load and evaluate code. So hijack kernel require and just re-implement it yourself. That's the only way we can transpile source code at runtime. This is just overriding kernel require with fallback to the original one if we failed for some reason to load the code. The way we re-implement require is built on top of two arrays which are responsible for loading features in Ruby. So load path is the array of locations of where to look for a particular feature. So feature is a kind of a path or name of a gem, for example. Loaded feature is an array of all loaded Ruby and shared extensions files, the absolute paths. So it's used to check whether we already loaded this feature or not, to make require work only once if you call it multiple times. And that's the way we can re-implement it in Ruby, and actually what we do in RubyNext runtime mode. So first we need to resolve feature path. It's just scanning the load path, trying to figure out is there a file with this path part, and if it is, return this file. Then we check whether this absolute path has been already loaded, and finally we read the source code, we transform this source code. This is where method reference actually is very useful. And then the magic happens here. We evaluate the source code on the specific constant called top-level binding. So this is binding of the main Ruby objects, which is the top-level context of the execution. And evaluating code in the top-level binding is kind of similar to just loading a file. So it works the same way as Ruby require, probably. Well, maybe there are some pitfalls I haven't found yet. And that makes it work. And this switch, RubyNext, this is not a kind of extension of Ruby interpreter or command line interface. It's just UbiNext. So RubyNext is expanded into require UbiNext, and UbiNext is just a file that loads all the runtime hacks. So that's make it possible to use this very beautiful notation to run in scripts using modern syntax. Okay, so yeah, runtime mode is definitely not for production, as it is now. But it's good for testing. We use runtime mode to test RubyNext itself. That's why actually it was built. And future version of RubyNext will likely have an integration with Bootsnap. Bootsnap also hijack require and all the other stuff, but well, it's kind of a mature library, and I hope they found all the edge cases, and we can rely on their require mechanism. So if we can integrate into this, we can make runtime mode really safe and doable in any application. A note about gems. So the idea is that we ship transpiled Ruby source files along with the original source code, because we don't want to transpile code in runtime, and we don't want to add additional runtime depths for our gems, except from refinement part of the RubyNext, because it's required for pattern matching, for example. RubyNext ship is a command line interface, RubyNext, with a command nextify, which performs a transpiling and create a directory in your project's root directory, so say lib, called rbnext, and put there all the transpiled files, only those files which we need to transpile, which use some features not supported by minimum required version you want to support. And then in your entry point of your gem, you only need to call this method setup gem load path, probably too long, which again use the knowledge about the load path and does the following trick. So it detects the current Ruby version, detects the corresponding RBNext folder with the transpiled files, and add this folder to the load path before the original library folder. That makes Ruby, for all the subsequent require calls, first check this transpiled files folder. If a feature is present there, use it. And if it's not, then go to the original folder. This way, we only add this folder to the load path, again, if we need to support this version. So for the latest version, nothing's going to happen at all. So this way, we can shape transpile file along with gems and make it kind of transparent. Well, everything I was talking about is available on GitHub, and it even works. Currently, we support most syntax features from 2.6 and 2.7, well, except from startless ranges, because, well, I haven't figured out whether we need them at all. And we don't support this new feature of pattern matching, which is called one-line pattern matching without case, because it haven't been released even in preview versions of Ruby. So, but it's going to be someday there. The question arises, what about compatibility? How safe it is to use this transpile code? How do we prove that it's correct? Well, to make it, not 100%, of course, because it's impossible, but to make it as correct as the Ruby implementation, we use two sources of tests. We do not write tests ourselves, mostly. We use the project called RubySpec, so the specification for Ruby language, so the collection of tests other implementations use to conform with the Ruby MRI. And, well, unfortunately, RubySpec is not ready for 2.7 features. There are no tests for pattern matching, for example. For those features, we use Ruby's own tests for this feature. So we just grab tests from Ruby. It's like a 1,000 line for pattern matching, and we make sure it works in all versions we want to support. That kind of guarantees that at least we transpile code the way Ruby implementation assumes it should work. It doesn't mean that it works exactly the same, because I don't think that every edge case is covered with tests in Ruby. But, well, at least we try. So what's next? What we can do with this, except from, well, funny, let's use modern features in every application and library we build. It's kind of just a pet project. But we can go a bit further. First of all, we can change the title of the talk to make all Rubies quack like a new one. And I mean, by all Rubies, I mean other implementations, which we have a lot of them. And this is a place where RubyNext could be useful because, well, all of this implementation will eventually re-implement the new features, but it will take some time. And it could be quite a lot of time. What we can do with RubyNext is allow users of these technologies to start using new features right now. So say with mruby, Alpo, Artichoke, Prism, whatever. So the two last one is actually mruby, but anyway. That's one of the way we can apply this idea. But there is more, I don't know. Yeah. I have 5 minutes, so. And half a cup of tea. What else we can do is this. That's kind of a new idea which I came up right, well, again, I'm going to mention this accident with method reference because I was kind of confused. So I see an opportunity for a project like this, maybe some different project, I don't know, to be more than just a fun tool. So let's cycle this talk and come to the upgrade question, new features. Will users start upgrade to 2.7 because we have new shiny features? I don't think so, because they're experimental. And that label's changed everything. I'm not going to use experimental features in my 10-year-old monolith because I don't want to rewrite them the day the Ruby core team decide they no longer need this feature. So I'm not going to use them. That's a problem. Experimental. Let's repeat one more time. And one more. And maybe we can call it experiments. But yeah, that's a word that actually changed. That's a very powerful word. And this word, they both really powerful. And they both distracting. So this word distracts the idea of giving an opportunity to use new features to community. So we need an experiment. But we first need to have to kind of come up with the process of experimenting, some guidelines. And why I think so? Well, that's two examples. Like Matt's already mentioned that there are some numbers. Pipeline operator survived 3.5 months. Okay. Method reference almost a year, and it passed the first release candidate, and it was canceled. And actually, no one knows why. Well, probably a few people, but they're not in this room. Well, it's clear that we don't have a process of dealing with new features, of introducing new things, new big things into the language. Let's take a look at how others do this. Again, JavaScript. I'm not a JavaScript developer, but, well, they have some good parts in their community as well. Oh, they have this TC39 committee, which works on the evolution of ECMAScript sophistication. And they have a process of passing features along the stages. And they have, for example, this candidate stage, which is very similar to what we have now in Ruby 2.7, experimental features. And there is an important point here. We require feedback from users, not from the committers, not from the core team, not from the implementation developers, from users. And even more, the already mentioned Babel is often used as a source of truth for committee to decide whether we want to add this feature or not. Let's ask users of Babel who already use this feature flagged by experimental, whether it's good or not. Can we improve it? That's the process. We don't have such process in Ruby, and we can't do this because it's impossible to evaluate a new feature using a hello world example. You need to try it in the application you're working on every day, in some kind of maybe production app, whatever. In real code, not in the synthetic example. So that's the big idea, which I don't know how to tell it to core team. Maybe I have to come to Japan to do that. But anyway, that's what I think about. If I want to work on this project, I'm going to make it something big and not just a tool to experiment with all the Ruby hackery. So don't wait for Christmas. Start using Ruby next. Thank you.